Let's now turn our attention to the normal distribution. The normal distribution is a fundamentally most important distribution that's used in statistics. Let's take a look at it. Here's a normal distribution of scores. Notice that it's symmetrical. It's the same on one side as it is on the other. Notice below this normal distribution, we've listed percentiles, VO2 max, standard deviation, z-scores, and t-scores. Importantly, all of the values below the distribution, those for percentile, standard deviation, z-score, and t-score, will always remain constant with the normal distribution. The only thing that will ever change is what the variable is that you happen to be looking at. In our case, it's VO2 max. Notice if you're at the middle point of the distribution, 50% of the scores fall below that. It's the 50th percentile. Likewise, there are 50% of the scores above the middle or the mean on a normal distribution. Similarly, you can look at areas between the plus and minus 1 standard deviation above and below the mean. 3413 plus 3413 gives us 68% of the scores. 68% of the scores fall between plus and minus 1 standard deviation away from the mean. Notice if you go out plus and minus 2 standard deviations, you encompass about 95% of the scores. That 95% becomes very important to us in statistics because there are remaining 5% of scores. Again, importantly, the only variable that will ever change in this illustrated distribution is that for the variable that you have interest in. In our case, it's VO2 max. Perhaps yours is test score, or bench press, or pacer laps, whatever it might be. Also notice that the z-score and the standard deviation are exactly the same. Importantly, tables have been developed that help us identify percentages of observations under the normal distribution. That's illustrated in what's called the normal curve table, or a z-table. Notice that down the left-hand side there are z-scores in whole numbers and tenths, and across the top are z-scores in hundreds. The numbers in the body of the table represent percentages. They are the percentages of observations between the mean and any given standard deviation unit away from the mean. For example, if you go out 1 standard deviation above or below the mean, you'll encompass 34.13% of the observations, just like we saw in the previous slide. This table will become very important to us. It's important for you to be able to go in and out of this table, realizing that z-scores are down the left-hand side in whole numbers and tenths, in hundredths across the top, and importantly, the numbers in the body of the table are percentages. They're the percentage of observations between the mean and any given standard deviation unit.